Good morning, good afternoon, and good evening. Thanks for taking the time today. Today we are going to be talking about running Oracle workloads in VMware Cloud on AWS. My name is Sai Gopalan, and I work in the VMware product marketing team, and I'll let the House of Brick team introduce themselves.
Hello, everybody. My name is Nathan Biggs. I'm the CEO at House of Brick, and also I get involved with our customers, helping them with cloud strategies, especially around licensing Oracle in cloud and virtualized environments. So glad to be talking to you today.
Hello, everyone. My name is Nick Walter. I'm a principal architect with House of Brick Technologies. I work with a lot of our clients on crafting cloud solutions that meet their needs for business-critical workloads. Happy to be here as well.
With that, let's jump straight in. We have a packed agenda today, so we're going to be covering an overview of VMware Cloud on AWS and talking about how running VMware Cloud on AWS Oracle workloads works. We're going to be talking about architectural suitability, tools, and migration. We're going to be covering a couple of customer stories as well. And then we are going to be talking about Oracle licensing in VMware Cloud on AWS. Finally, we'll be covering what's new and leave you with a few resources. So with that, VMware Cloud on AWS is a jointly engineered cloud service between VMware and AWS. And this really brings VMware's software-defined data center technologies to the AWS cloud. VMware vSphere, vSAN, NSX are running on elastic bare metal AWS hosts, and the customers and the users get a vCenter access. Now, this offering is a cloud service. It's sold, operated, and supported by VMware and its partners. That means you as customers do not need to worry about the software upgrade lifecycle management. We do that for you. Because this is a cloud service, it comes with on-demand capacity and flexible consumption models. Now, the key thing over here is that we are basing everything off of vSphere and vCenter APIs, so there is full operational consistency with on-premises software-defined data centers. And this is a really key point about VMware Cloud on AWS, which really helps our customers build a hybrid cloud solution. Because there is vSphere on both sides of the equation, there is seamless large-scale workload portability and hybrid operations that's possible. Simply at the right click of a button, you can do a vMotion of workloads over to VMware Cloud on AWS and back. We will follow AWS's global footprint and reach and availability over time. And we don't just stop with the power of VMware software-defined data center technologies running on AWS Cloud. For virtual machines that are running inside of VMware Cloud on AWS, they have seamless, high bandwidth, low latency connectivity to native AWS services, which really opens up a paradigm of integrated application modernization. We're very excited to say that we've been in the market for 1 year now. VMworld US 2018 marked the 1-year anniversary of VMware Cloud on AWS, and this offering is really used by our customers in a variety of ways to solve a variety of needs. On the far left, you have the data center extension use cases, where customers want to extend their data center for new project capacity or for on-demand capacity for seasonal spikes in demand. They also want to be able to run virtual desktops on VMware Cloud on AWS as an extension to their on-premises footprint. They also want a test dev environment that's consistent with their production environments on-premises. In the middle, we have disaster recovery, which is a very popular use case. And this essentially breaks down into customers that want a DR strategy. They don't have a DR strategy or solution in place. They want a cloud-based DR, and they use VMware Cloud on AWS for that. Or they are not satisfied with their existing DR solution, and they want to replace their existing DR solution, or in some cases, even shut down their secondary DR sites and move that to a cloud-based, elastic, DR solution with VMware Cloud on AWS. And then finally, we have customers that want to complement their existing DR solutions for Tier 2 or Tier 3 workloads, and in some cases Tier 1 workloads as well with VMware Cloud on AWS. In the middle, we have cloud migration as well, and this is a spectrum of use cases. Some customers want to be able to migrate specific select applications, and we hear mission-critical applications quite a lot in our conversations with customers to VMware Cloud on AWS. The key thing over here is that there is absolutely no rework or re-architecture required because it's all based on ESXi. There are some other customers that want to basically consolidate their data centers and move entire data center workloads over to VMware Cloud on AWS. And then there are certain other customers that want to opportunistically use infrastructure refresh projects and use that as a way to adopt the public cloud in a consistent manner with VMware Cloud on AWS. Finally, we have customers that have started to explore building out next generation applications as well as modernize their existing applications with VMware Cloud on AWS. This service is the best for any type of migration, whether it is application specific, infrastructure refresh triggered, or data center wide migration. If you actually look at, speaking to our customers, essentially the migration time and the migration costs, the biggest component of this is application rework. And as I was mentioning, with VMware Cloud on AWS, we solved that fundamental challenge by providing a consistent infrastructure layer that is present on-prem as well as in VMware Cloud on AWS with an ESXi-based infrastructure layer. With that, let me hand it over to Nathan to take us over for running Oracle in VMware Cloud on AWS.
Thank you, Sai. Glad to be talking with you today, and I think that this is an exciting thing to be discussing, running Oracle in the VMware Cloud on AWS. Just a quick introduction into House of Brick. We're a customer-focused service provider. So while we're partnered with VMware and also with AWS, we don't resell those products. We're focused on the services and the enablement that customers need, whether that's technical and architectural services, strategy development, also license services so that customers understand Oracle license compliance, as well as preparing for and defending themselves in an audit. So those are things that House of Brick focuses on. We also have SQL Server services in addition to Oracle. So what I'm going to talk about first, for just a few minutes, is kind of the market, what we're seeing in the marketplace related to cloud computing and specifically with Oracle workloads. I'm going to turn it over to Nick to talk about some of the architecture and the migration considerations, and then I'm going to come back after Nick and talk about licensing considerations in the cloud, because that's something that everybody is thinking about and probably worried about a little bit. So let's talk about what's going on in the industry. Back in 2006, House of Brick worked with our first customer on a virtualized platform to put their Oracle e-Business Suite into production on VMware. Now, this was a very early version of VMware, and nobody told us that we should have any concerns about it. We just thought that VMware was a terrific platform, and our customer agreed. This was a very large food services customer in the U.S., and we helped them go live with their e-Business Suite application in a virtualized environment back in 2006. But it took some time for customers to really adopt and get comfortable with virtualizing Oracle. There were concerns about performance and licensing and other things, and so it took a while. What we're seeing now, however, is that when it comes to virtualizing Oracle, it's pretty much standard operating procedure for most of the organizations that we come in contact with. Just about everybody is or is considering virtualizing their Oracle. So we put this in the late majority phase of the technology adoption. Virtualizing Oracle is pretty much standard best practice at this point. When it comes to the cloud, however, what we're seeing is that cloud adoption for Oracle workloads and other business critical systems is just getting started. I was with a customer last week in New Orleans, Louisiana, and they asked, and they said, hey, when I talk to people about cloud computing, they tend to say that everybody is already in the cloud, and if you're not there, then you're behind everybody else. And he said, I don't feel like we're behind, but when it comes to Oracle, we're just now considering a cloud strategy. And frankly, that's what we're seeing with everybody. Now, there's a lot of things that go into the cloud, and cloud is a very well-established process and technology. But for running Oracle in the cloud, really what we're seeing is that we're in the very early stage of that. In the innovator, early adopter stage, as far as the organizations that we work with, and we work with hundreds of organizations from very big to very small around the world, putting Oracle in the cloud is still a very early conversation, a very early strategy. And there's still a chasm to cross for many customers. How do I get my Oracle workloads into the cloud and develop a cloud strategy that lets me take advantage of all of the processes and expertise that I've put in place, especially around my virtualized environment? So some of these cloud adoption barriers that people are thinking about, whether they're real or perceived barriers, and really more of the perceived barriers on the right-hand side. Some of the real barriers that we need to address are on the left-hand side there. So on the right-hand side, vendor support, whether that's Oracle or Microsoft. We've got support for running in the cloud, security, performance. All of those things are things that we can address very, very comfortably. On the left, though, before VMware Cloud on AWS, it was difficult for customers to extend their current software-defined data center into the cloud because of that lack of compatibility. So the VMware Cloud on AWS really opens up an opportunity for customers to migrate their existing software-defined data center into the public cloud. So we call this opening a window to the cloud for our Oracle customers. The VMware Cloud on AWS is a seamless operational and architectural benefit to our customers. So all of the things that Sai talked about, the seamless extension and operation, really is a wonderful thing for our customers who have put Oracle in a virtualized environment in their software-defined data center, and now they want to extend that naturally into a public cloud. The VMware Cloud on AWS is just a wonderful solution for that, really addressing that barrier that customers had perceived before. The other barrier that we talk about, though, is licensing. Let me give you a quote. Last year at VMworld in the U.S., during the opening keynote presentation, VMware had up on stage Karine Semmer. She is the head of IT Hosting Transformation and Modernization Program at Medtronic. And so she had been using the VMware Cloud on AWS as an early adopter and looking at how it would fit with her organization. And she made this comment, and I picked it up because we focus a lot on licensing and concerns that customers have. She said, the one challenge which I think many of you will recognize if you have done anything contractually around licensing going from on-prem to cloud, that again is our more significant challenge, one that is true for the cloud industry. So licensing Oracle in the cloud really is the bigger concern. It's a big concern for customers even in a VMware virtualized environment, but going into the cloud just raises more questions that customers have. So I'm going to come back in a few minutes and talk about licensing in more detail, but I'd like to turn things over to Nick here and let him talk about some of the architectural considerations for migrating and running Oracle in the cloud.
Thank you, Nathan. Happy to talk about that. One of the things that a lot of people ask me when I first raised the topic with them of running an Oracle workload and a business-critical Oracle workload in a cloud environment is really suitability. Is this going to be a suitable environment for my business-critical application? And people are talking about their e-business, their payroll, their CRM, some of their key things that drive their business. when we talk about some of these big, expensive applications. And they've probably invested significantly in their traditional on-prem data center footprint to make it highly redundant. And a lot of effort and engineering has gone into that. And you hear some nervousness about, okay, well, I've heard, you can go to the cloud and virtual machines can disappear randomly or failures are possible, or is this a suitable environment? Will it perform? And I always go through a checklist, and this is my simple checklist for is something suitable for a business critical application. I want to know if it's performant, highly available, secure, compatible with all the things I need to be compatible with, and extensible into the future to avoid extensive lock-in problems. And I'll talk about each of those in a little bit more detail. The performance in VMware Cloud, based on all the work I've done in it, and I have helped multiple customers move workloads into VMware Cloud, either production use or pilot projects, so I'm fairly familiar at this point in time. Traditionally for the last year, the VMware Cloud has offered these i3 Metal nodes. i3 Metal is the AWS name for the type of host in the clusters in the VMware Cloud. And just announced very recently, I don't even know if these are in G yet, but they were announced at VMworld very recently, is the new R5 node types as well. And I'm not going to go into a bunch of detail on these specifications. Obviously, you can see them here. But the key is that the clusters, the vSphere clusters that you build and host your workloads on when using VMware Cloud are highly performant systems. So there's plenty of horsepower here for the business critical applications. And sometimes business critical applications, because they're so critical, can be very, very performance sensitive. I'm thinking in terms of big data warehouses that have to run massive reports and it's not acceptable for them to be late. Or online transaction processing systems, especially in the finance industry, where latency is a super key concern. And I've been able to move both kinds of platforms to the VMware Cloud with acceptable performance. We've got Xeon processors all around. The new R5s have a little bit faster processor and a little bit more RAM. For those wondering what I mean by logical processors in this slide, that is the term you see in ESXi, VMware ESXi. It corresponds to hyperthreads, for those of you more familiar with that term. The networking is fantastic. It's the 25 gig networking that is available in all of the larger instances in AWS. So for those familiar with that, it's 25 gigabit NAs. And then the i3s have something that anybody in the audience with DBA experience is going to get excited about, which is that NVMe SSD local storage. So very high speed local storage. The R5s have slower storage. It's actually using Amazon's Elastic Block Store. I believe it's GP2 tier, though I'm not 100% on that. So there's a little bit more storage available for the R5s, though it is slightly slower storage. So it's good to have the choice available. If you have a real compute-heavy workload, clusters of the R5s might be a better fit. If you have an I/O-intensive workload, like, for example, an Oracle database, the i3 might be a better fit. VMware has done a white paper on the performance of this. I've read this white paper, but I did not participate in any of these tests. I'm not an author on this one, so I can't speak to it with great authority. But it is an interesting read, and it shows kind of horizontal, vertical scalability patterns in the VMware Cloud as you spread workloads across clusters, or you saturate one node with a bigger and bigger virtual machine, and it kind of demonstrates good scalability in all directions. The resiliency is a big one that people ask about because they're very concerned about their business critical application, and they want to know, is this going to be highly available? I had traditional issues with my vSphere on-prem having to allocate extra hosts so that I could take certain hosts out for maintenance or to have N+1 configurations, things like that they're used to doing, and they want to know if this is going to work well in the cloud. The good news is it's a pretty excellent solution. First off, for individual virtual machines running in your clusters in the cloud, you have VMware HA, same as some of you might be familiar with from on-premises vSphere installations. And that's just functionality that says if an individual host in a cluster fails, the VMware stack will, as quickly as possible, restart those virtual machines on a surviving host. And it's quite good at doing this. Generally, you're looking at 3 to 5 minutes, and your workload's back online. And for those of us who remember back in the day, playing with expensive, multiple clustered stacks and setting up multicast networking and shared storage, it's amazing to get this, sort of out of the box as just a standard feature. At the entire host level, if you're worried about having to allocate extra hosts or pay for extra hosts, you don't need to do that because this is a cloud service. So if a piece of hardware in one of your clusters in the cloud goes away, another one is going to be added in the background for you automatically. You don't have to over-provision to get that capacity. The storage in these clusters is managed with vSAN, which is a very interesting technology that unifies disparate server local storage and makes it look like one big shared storage array to the entire cluster. But vSAN does have striping built in, so as long as you use your default redundancy policies or even better ones, no single host outage in a cluster can cause any loss of virtual machine data. The data will persist even if the virtual machine got knocked offline suddenly and come back up somewhere else, and all its data is still there. For those of you familiar with Amazon, there's also the concept of regions and availability zones. Availability zones are distinct data centers within a geographical region. And so if you want that multi-data center availability, the best practice for years in Amazon has been to make sure that you distribute your applications or your instances across multiple AZs. You can do that in VMware Cloud as well, not just on a cluster level, one cluster in this AZ, one cluster in that AZ, but you can also do stretched clusters where some cluster members are in one AZ and other cluster members are in another availability zone. So if you're worried about high availability, that's a good tack to take. And then the beautiful part about any cloud service, of course, is that somebody else is doing the care and feeding. And with the VMware Cloud, the patching and the maintenance for the underlying hosts and the underlying ESX and the underlying vSphere is all handled for you automatically. There'll just be maintenance windows where the machines get migrated off of a host, it goes down, patches, comes back up. If it's long enough, an additional host might be added automatically for you in the background to keep the node count high enough for your cluster's workloads. Very seamless, very smooth activity. And of course, anybody worried about business critical applications is going to have concerns about security. This is a big one. Nathan touched on it as well. People starting to move business critical applications have business critical data. They may have all of their customer information. They may have things they need to worry about PCI compliance or HIPAA compliance on. I know that's a struggle for a lot of people in moving things to the cloud that they'd like to, is can't get the appropriate sign-offs from our internal security or data privacy officers. And the VMware Cloud has excellent protections in that regard, much in line with what AWS already does for those familiar. All back-end data is encrypted at rest, so there's no danger that somebody could physically break into a data center and walk off with a hard drive and at their leisure consume your data. Also, and I like this a lot, the clusters that you define in the VMware Cloud exist in Amazon Virtual Private Clouds, VPC containers. So it's a private networking band area that is kind of cut out of the public cloud so that all of your virtual machines are in a private addressing space. And you never have to put public IPs on anything or even allow public connectivity into them. As a matter of fact, the majority of people I work with never do. They define a virtual private cloud area with addressing that is in line with their company data centers. Maybe they play with linking them together, IPsec tunnels, or using AWS Direct Connect to connect. And if they're on-prem data center, this is hypothetical, is 10.0.0.0 bands, then they carve out 10.0.23 something for their cluster in this region, and they put another VMC cluster in another region and give it 10.0.24.0, connect them all with IPsec, and all of their resources in the VMware Cloud can be treated as if they were in private company data centers, firewalls, no public access to them is allowed in via VPN, that sort of security. So the network security is definitely up to par with the same sorts of things you can already do with AWS, and it offers excellent network security. They do have this NSX product, which is a pretty good product, and some people see that and say, well, I'm not using NSX in my on-prem vSphere yet, and this is a great networking product, but I don't want to retrofit my on-prem, so would I be able to take advantage of this when I'm in VMware Cloud? And the answer is yes. The VMware Cloud, because it is a cloud offering, you don't get to install or customize the base install. He's saying you're going to get a certain version of vSphere. You're going to get NSX. It's just built in. To use some of the features, you do need to have at least an appliance that they provide, an NSX Edge appliance that you install into your on-prem, and that's only if you want to do some of the features like stretched layer 2 networking, things like that. The NSX that's in the VMware Cloud, yes, you can configure very complex firewall rules, network security rules, and so forth, and you don't have to do anything to change your on-prem footprint at all. Some people have that concern when I talk to them, so I wanted to emphasize that. The compatibility, this is, I think, really the strongest part of the VMware Cloud story. vSphere traditionally is sort of the best of breed on-prem virtualization solution. People use it for all sorts of things. Works great, compatible with every major Linux, all of the Windows servers that are current. I imagine dig out a really old one that wasn't. And over the years, even the application vendors that really like to drag their feet and be fussy, and I am thinking Oracle when I say that, have had to grudgingly admit that yes, this is a completely supported platform for running our applications. It's very widespread. So being able to say, okay, this is extremely common, we have a lot of investment in it, or other people in our industry have a lot of investment in it, there's no danger, it's a low-risk platform, it's well-known. Being able to say, I'm going to the cloud, but I'm keeping hold of this well-known, well-supported platform that none of my application vendors are going to complain about, that is a very compelling reason to use VMware Cloud, at least among the customers I've talked to. And from a compatibility aspect, I highlighted a few things in this slide that VMware Cloud does, and it's not shocking for those of you familiar with on-prem vSphere installations to say the VMware Cloud does this, because it's always done it on-prem, but these are things that other cloud providers traditionally struggle with. Anybody who's tried to set up clustered products to migrate a clustered application directly into AWS knows that AWS doesn't support multicast networking. It doesn't support multiple readers and writers to elastic block store volumes. So some products you really have trouble finding a workable configuration for in AWS, whereas it's just snap to set those things up. Oracle Real Application Clusters is an excellent example of this. If you want to do Oracle Real Application Clusters in AWS, you have a lot of problems. There's third-party packages and products you can leverage to try and make it work. And I'm not saying it's impossible because I've seen it done and worked on projects where it's been done, but there are a lot of concerns around it, whereas it's just easy as 1, 2, 3, snap your fingers in VMware Cloud. And well, some of the earliest customers I worked with said, well, we have workloads, we have legacy applications, we have legacy Oracle applications, so we can't stop using Oracle Real Application Clusters. How do we get this to the cloud? Every attempt we've made has been painful and required a lot of engineering time, re-architecture. This is a big concern. This is a showstopper for us. And I said, well, you're going to kind of laugh, but it's going to be as easy as we're going to connect your on-prem vSphere environment to the VMware Cloud. We're going to right-click and we're going to start migrating it. And we'll get into migration tooling here in a bit, but it really is a very straightforward path because the VMware Cloud has excellent compatibility. And then the other thing to worry about with a business-critical application platform is you want to avoid lock-in traps. You want to avoid going with the technology that looks great now, but in 5 years you're going to really regret being on it and you're stuck. A lot of people have been trapped in these before in the IT business, so I don't think I need to explain that anymore. But the beautiful part about the VMware Cloud is that it has this built-in compatibility and extensibility directly into Amazon Web Services because that's where it runs. It runs inside of Amazon VPC. And Cy touched on that earlier as well. So for clients that get caught in this kind of push and pull, a lot of the IT directors, CIOs that I talk to say, well, on one side, I've got my development staff telling me, listen, we want to go cloud native. We want to go serverless. We want to develop all these cool new apps and take advantage of these things. We need to be in the cloud. And the other side, you might have, operations or development teams supporting applications that are built, maybe even legacy applications, but applications built on Oracle technologies, heavily invested in on-prem stuff, and they say, there's no way inside of 48 months we could re-architect and refactor all this stuff to go to the cloud unless you're going to sign off on millions of dollars worth of more headcount so that or contractors or whatever, to give us the manpower to do this. It's a major pain. VMware Cloud lets you solve both problems. Instead of being pulled in two directions, opposite directions, now you can both of those groups and say, we're going over here to the VMware Cloud and we're all going along. The legacy applications are very, very finicky, very tightly coupled. The operating system configuration has to be just so. The database configuration has to be just so. The application configuration has to be just so. Those work really well in VMware Cloud and can basically just move right over very painlessly and quickly. The stuff that you want to do going forward with the brand new ideas from the developers, well, you're already in AWS. So of course you can start playing around with your serverless implementations and give your serverless applications local speed access to your legacy applications in case they're sharing data, there's interchange components. I've seen people love this because, they had a legacy application that was OLTP-based Oracle RAC cluster. I think it was 9 or 10 version. So they'd had it for a long time, didn't really want to invest in changing it because it worked well. But their reporting and data analytics team, they really wanted to use some modern tools. They wanted to get this data into Redshift. Moving into VMware Cloud presents a path to do that easily. Now your legacy Oracle RAC cluster is in the cloud. You have local access feeds to it. And if pieces of your applications deprecated or get modernized, now you have the path to say, I'm immediately going to replace this with a component that's native to AWS. Uses Elastic Beanstalk, maybe just uses Cloud Front and S3. There's all these great technology you can suddenly leverage without breaking backwards compatibility with the things you've already done. And I just love that because so often in the tech world, you get pulled in the direction of either do the new thing, abandon the old thing, or stick with the old thing, you can't do the new thing. You can do both in VMware Cloud. I do want to talk about the tooling because once I tell people, okay, VMware Cloud is a great platform, good place to run your Oracle applications, they say, how hard is it to manage? How hard is it to get in there? And I think there's a pretty good story here. This is just kind of a high-level slide with, generic migration challenges. Anybody in the audience who has worried about doing cloud migrations before has probably encountered these, but it's basic stuff. Do you have to convert VM formats? Do you have to re-architect applications? How do you move a whole bunch of things at once without taking an extended downtime? Obviously very unacceptable. Can you bring things back if you change your mind or locked into this? Is this a one-way and you burn your bridges? And of course, what are the costs? And there's a lot of tools in VMware Cloud that are going to make this a lot easier for you. There's actually probably 4 things I talk about with customers. And there's a kind of a variety of tools available for migration that you might want to use depending on your particular circumstances. There's a variety of answers. And I'll get into kind of why you might choose different ones. The first one that I like to talk about is hybrid linked mode. And hybrid linked mode is available if you are already on a version of vSphere in your on-premises VMware environment and you want to link it directly to the vSphere environment provided by VMware Cloud. So for a shop that's already really heavily invested in VMware, maybe all through their data centers, and is relatively up to date on their versions. I believe at least 6.5, might be 6.7 you have to be on to use this feature. Then you can enable what's called hybrid linked mode, which lets you use the vCenter in the cloud as sort of a single pane management, where it shows not just the cloud vCenter, but also your on-prem vCenters all through one view. And from there, you can very quickly just right-click any virtual machine in your on-prem data center, and it's just a VMware migration at that point in time. Just like you might migrate things between clusters on-prem, you can just say, migrate this one to a cloud cluster, please. It does. So it's really easy to use, really intuitive, no retraining. All staff currently skilled in operating vCenter will take to this like a duck to water. So that's a great tool. But it does have those strict versioning requirements, which kind of knocks it out of consideration for some people. The next one that I always talk about, and I talk about this one a lot during mass migrations, is VMware Hybrid Cloud Extension, which I think they just announced they might rename that. Right now I'm going to call it HCX, because that's what I've traditionally called it. And Hybrid Cloud Extension is a set of tools that VMware put together that let you, basically it's exactly for migrating workloads to and from the cloud from on-prem data centers, and several of the features you need there. This is a really good tool. Unlike the hybrid linked mode, which doesn't require you to have anything except for the right version of vSphere on-premise, this does require you to install some appliances into your local vSphere, one of which will manage like WAN links and encryption, and will set up IPsec tunnels for you, manage, block copies, basically migrating virtually to the cloud. So it's a little bit heavier weight to install, but it doesn't have the version requirements. Like if you're on vSphere 5.5 still in your on-prem data center, HCX is no problem. You can use that. I think you might even be able to go a little older than that, but I'm not sure, so I don't want to speak to that. What it does that I love from a cloud migration perspective is A, it provides IPsec tunnel functionality built in, layer stretch network functionality built in, and it has a mass migration toolkit. And it's a mass warm migration toolkit as well. And this is important because a lot of people miss this or hand wave this off when they're looking at doing a big data center evacuation or moving a big chunk of an application to the cloud. They say, well, we have a lot of bandwidth, maybe we have direct connect, or we just have really big circuits and we can set up the VPN to copy our data up to the cloud. And that works great when they're testing or when they're just doing a little proof of concept or pilot exercise. And then they go to move, the whole shooting match, the whole big application of the whole data center, and they go, oh wait, we have how many terabytes of data? Simple math says that's going to take weeks to copy them to the cloud over network. What HCX does about that is it mirrors virtual machines in the background and won't cut them over to the cloud until they're done. So if you say, okay, I've got 100 virtual machines that comprise maybe my non-production application test environment stack, and I want this entirely moved to VMware Cloud from my on-premises data center. You can select them all in Hybrid Cloud Extension Management Console and say move all of these at one synchronized time to the cloud. And that synchronized time will be 4 days from now. And what it will start doing is mirroring the backing storage of those virtual machines, so all their virtual hard disks will get mirrored up to the cloud in the background over these 4 days. And then once it reaches the cutover point, it shuts down the on-premise virtual machine, does a final sync of any storage, and starts them right back up in the cloud. So you're looking at a situation where, yeah, it takes you 4 days to copy the workload to the cloud, but you can spend that 4 days without an outage. You can keep your workloads hot and just take a small outage when it's time to go. Site recovery is a tool that is used primarily for disaster recovery. So when you're using VMware Cloud as a DR target, which some people find attractive rather than paying for their own data center, you can use Site Recovery Manager for mass migrations as well, because it, again, has that functionality to mass copy virtual machines. But that's not its primary purpose. I only bring that up for sites that are already licensed for it and are doing DR testing. And then the absolute worst case scenario, but I mention it in case somebody says, what about all these things? I can't do any of them. Well, yes, You can just cold migrate virtual machines. You can copy them up to S3 or directly in and just cold migrate them one at a time. It's painful. I don't recommend it. I just did it for sake of completeness. Okay. The migration challenges, and I think we've already covered these, so I won't go into great detail. But architectural refactoring is a big pain point for people moving things into the cloud. And the nice thing is that if you've got your on-premise x86 environment the way you like it, even if it's not virtualized yet, you just do a simple physical to virtual transition and then move it directly to the cloud. Clusters may need a little special care, but it's really not that bad. Bandwidth, I already touched on, can be a big challenge once you actually start migrating in volume. So finding ways to live mirror workloads or tools for that is important. And then one that people often miss is cross-site dependencies. So you migrate all of these applications to the cloud data center. And so now all these applications in the cloud need DNS. They need your corporate DNS. They need your corporate AD, corporate LDAP, corporate backup tools, corporate security tools. If you're backhauling all that traffic over an internet IPsec tunnel back to your corporate office, the latencies can get very painful. So I always encourage people, don't just move the application workloads, think about the surrounding things it needs. Maybe it's time to establish an AD node in VMware Cloud. Maybe it's time to get a backup server in the VMware Cloud so that stuff's local. So that's what I tell a lot of people. I just wanted to do a couple quick stories about some customers that I've worked with doing this. I did work with a very large governmental agency about 6-7 months ago, and they were looking at a DR data center, and they had a very large DR data center that was a cold data center. It was receiving replication from the primary data center, but it wasn't an active-active configuration. There was nothing in use in it. And they were paying an awful lot of money for this building and for the servers, and it was all on a just-in-case basis. They'd never actually had a DR event, but they were paying millions and millions of dollars every year to be ready in case they did. And they said, well, wait, why don't we use the VMware Cloud for this? And with the cloud capacity expansion on demand available from the VMware Cloud, they could provision a much smaller VMware Cloud environment, enough to just fit the most critical apps, and if they actually hit a disaster, the plan was, well, we would add nodes. We would grow and bring the workloads online, sort of grow on demand using cloud elasticity and flexibility to save ourselves a lot of money. I worked with them on that. They had a lot of Oracle and SQL Server databases, hundreds of them. They were really concerned about how to mirror things over there with a good recovery time objective and recovery point objective. And what we ended up doing is we used Site Recovery Manager from their local on-prem vSphere environment to replicate their virtual machines. They were very much a VMware shop. All of their workloads were already virtualized in VMware. So that they reached the cloud as site recovery mirrors of their key systems. We could test DR failover to and back. We could prove that their Oracle RAC clusters worked. Their SQL Server availability groups worked. The only thing I call out on this, in case people are curious about this, Oracle RAC traditionally doesn't work with Site Recovery Manager because of the multiple nodes sharing one disk aspect of it. So for the Oracle RAC databases, of which there weren't that many, there were 5 or 6, but they were their most mission-critical databases, we kept those hot in the cloud at all times and used Oracle Data Guard to mirror data to them. The rest of their databases and all of their SQL Server availability groups were mirrored with Site Recovery Manager. And like I said, we set this all up. We did test failovers, test failbacks. It all worked just amazingly well. The other one I'd like to talk about, this was a fun one. I did this one just over the last few months. Very large financial organization, and they were kind of in this trap I alluded to, where 30% of their apps had already been migrated to AWS because their developers had wanted to go do new things and play with the cool new technologies, and there was a lot of cool new technologies out there that saved them work. So now they kind of dipped a toe into AWS. They had multiple VPCs. They had a pretty robust AWS setup already in place. And then they started looking at, well, now we're paying for a data center that we've kind of 30% evacuated, but we can't get any, it's all or nothing. We can't pay for only 70% of the data center. They own the whole thing. I said, well, let's just get out of this data center entirely. And they went to their people and they said, okay, how are we going to move all these legacy applications? Because they were an Oracle shop for years and years, so we did a ton of WebLogic development. A lot of internal applications were all in Java and Oracle WebLogic. And for the newest stuff, it wasn't that hard, but they had a lot of like WebLogic 10 early versions and so forth. And they were looking at the refactoring costs and saying, well, this is going to take a year, this is going to take a year and a half. And then, VMware brought to them the idea of the VMware Cloud, the opportunity to work with them. And I showed them HCX setup. Let's just do layer 2 stretch. Let's just mass move virtual machines. And when they started moving 20 virtual machines a day to get 200 legacy applications done inside of a 30-day window, more on weekends also being moved. Just an astonishingly fast cloud migration, one of the fastest I've ever seen, and it all worked flawlessly. Well, I shouldn't say flawlessly. Nothing ever works flawlessly. There were surprisingly few road bumps, and they were easily addressed. Even in their very complex networking setup, lots of VPCs, and we were able to just slot VMware Cloud right into their existing cloud architecture, played well with everything. Fantastic. Now I'm going to turn it back over to my colleague Nathan to talk about the licensing a little bit more.
Thanks, Nick. Yeah, let's talk a little bit about the licensing. Let's start first with the definition from your Oracle license agreement on where you have to have a license for, and this is for processor-based applications like Oracle Database. So this is from the agreement. It says processors shall be defined as all processors where the Oracle programs are installed and or running. That's a pretty simple definition. You just have to have a license where Oracle is installed and or running. One of the challenges is that Oracle tends to expand that definition a little bit, mostly in sales conversations, sometimes in audit situations, where they say that you have to have a license where it could be installed or could be running. Well, there's nothing in the agreement that says that. You may have seen this comic before that House of Brick put together, the Oracle parking garage. The guy's coming out, $1 million to park my car? And the parking garage attendant said, well, we had to charge you for every spot since you could have parked anywhere. So that's not how parking garages work. You pay for one spot that you park in. That's also not how licensing works. You pay for where it's installed and or running, not where it could run. So in the traditional licensing sense, you have to count all of the physical CPUs on the server where Oracle is installed and or running. You can't count virtual CPUs. So using the processor-based licensing, you count the physical cores, you multiply it by the core factor, and that's how many licenses you have to have. Oracle does have a cloud policy, and this is a statement of which environments qualify for the cloud policy. Out of the link that's provided there to the Oracle cloud policy, it says that it applies to cloud computing environments from the following vendors: Amazon Web Services, Amazon Elastic Compute Cloud, EC2, Amazon Relational Database Service, RDS, and Microsoft Azure Platform, collectively the authorized cloud environments. So in the cloud environments, according to the cloud policy, you don't count physical cores, you count virtual CPUs. Now, one of the restrictions is that you cannot run rack with the cloud policy. It's excluded by Oracle from the authorized applications that can run using this per vCPU cloud licensing. So we have questions from customers that say, well, in the VMware Cloud on AWS, which policy would apply? And the answer is you have options. So this chart shows the different deployment types that you have within Amazon: RDS, EC2 Compute, the VMware Cloud on AWS, dedicated hosts on EC2 or EC2 bare metal instances. And so with each of these deployment options, and I'll focus particularly on the VMware Cloud on AWS, you can't you can't get the license included that AWS provides for standard edition database as they do with RDS. Now, I'm not sure how that's going to be affected by the new announcement that RDS is available on VMware, so we'll see what comes of that. But if you have for our customers in the VMware Cloud on AWS, we tell them you can either, because this is EC2 as defined by Oracle, you can use that cloud policy and count virtual CPUs. You can also use your core-based licensing because these are dedicated hosts with the VMware Cloud on AWS, and you can count the cores on those hosts. Or if you have an unlimited license agreement, you can apply that as well. So really you have options that you can choose from in the best way to license your Oracle environment in the VMware Cloud on AWS. We talk to people about how to reduce the size of their environment or optimize the Oracle licenses in the VMware Cloud on AWS. And so you look for things like choosing Standard Edition instead of Enterprise Edition, reducing the cluster sizes. VMware has announced smaller cluster sizes for the VMware Cloud on AWS, so consider smaller cluster sizes. Consider an HA and DR solution that it doesn't have to be licensed for Oracle. For example, if you're not installed and or running at the secondary site, then your DR strategy wouldn't have to have that site licensed. Or also core disabled hosts, which is something that VMware announced at the recent VMworld conference, where you can get hosts with reduced core counts so that you have all of the memory and the storage capacity, but you have fewer cores that you have to license. The main thing for optimizing your Oracle licenses is to start small and grow into it. Don't try and do a lift and shift where you take your current environment and put it right into the VMware Cloud on AWS. It probably will have a huge licensing impact, and you need to carefully develop the strategy. This chart is something that comes out of a white paper that House of Brick wrote. It's available on houseofbrick.com if you'd like to go download that. But it shows the cost of the VMware Cloud on AWS running Oracle compared to the Oracle Infrastructure as a Service offering and the bring your own license aspect of Oracle Cloud. So comparing it to Oracle bring your own license, it really is as the deployments get bigger and your requirements are for bigger Oracle workloads, the difference between the cost of the Oracle Cloud compared to the VMware Cloud on AWS, the Oracle Cloud starts to get more and more expensive compared to the VMware Cloud on AWS. But really, the potential cost savings are dwarfed by the other operational and architectural considerations that you have. The benefits that the VMware Cloud on AWS give you really far outweigh the cost differences that might be there. So next steps, go to houseofbrick.com. Check out the white papers we have there. We have a white paper on running RAC on the VMware Cloud on AWS that we wrote with Amazon. We've got the Oracle on VMware Cloud on AWS total cost of ownership white paper that we wrote for VMware. We also are doing fully funded Oracle and SQL Server on VMware Cloud on AWS proofs of concept. If you want to develop something, if you want to dip your toes in the cloud for Oracle, then give us a call. We have some funding available to provide that consulting and the infrastructure that you would need to give that a try. And then also check out our recordings of the U.S. presentation at VMworld and also coming up in Barcelona in the next couple of weeks. So, Sai, back over to you.
Thank you, Nathan. So let's talk about what's new with VMware Cloud on AWS and the announcements that we made capabilities-wise for VMware Cloud on AWS. Just a couple of reminders. Our public roadmap is available on the link below, so you can actually have a look at it. We are very transparent with our roadmap and the way we categorize our feature life cycle. So with that, let's go into what's new with VMware Cloud on AWS. And essentially, what we announced at VMworld was new capabilities that allow our customers to accelerate their cloud migration projects, along with a new region in Asia Pacific. Now, we also announced a new high-capacity storage option that was backed by Amazon Elastic Block Store, smaller cluster sizes, as Nathan was mentioning, and we announced improvements to our hybrid cloud extension with accelerated live migration of large number of workloads with instantaneous switchover. We also announced several capabilities around optimizing enterprise licensing for applications that are licensed on a per core basis. And last but not least, we announced a set of capabilities that allows NSX to integrate with AWS Direct Connect as well as provide microsegmentation security. So let's look a little bit deeper into each one of these. One of the things that Pat Gelsinger and Andy Jassy announced at VMworld was the expanded global reach and the accelerated rollout program of VMware Cloud on AWS to all AWS regions. And as you can see, we added Asia Pacific Sydney region, and previously we were adding one region per quarter. And with this new rollout plan, we are accelerating it to 4 regions per quarter based on what our customers are asking us for. And essentially, if you think about it, what this means is our customers can now utilize VMware Cloud on AWS when that region becomes available, and they can really spin up entire VMware software-defined data centers in under 2 hours, right? With vSphere, vSAN, NSX, all of that instantiated. And they can add hosts within minutes. We talked about migrating thousands of workloads with zero downtime with a new capability called Cloud Motion with vSphere Replication. Essentially what happens, and Nick had covered that in the past, but basically vSphere Replication proactively replicates the data over to VMware Cloud on AWS, and at a pre-scheduled cutover time, the VM or the vMotion operations begin. We also announced new high capacity option with R5 metal that leverages Amazon EBS. And essentially this is used for augmenting existing SDDCs for storage dense environments. And what happens in the background is vSAN actually utilizes Amazon Elastic Block Store, making it like Elastic vSAN, right? And essentially what customers can do is when they are actually provisioning their hosts, they can select from a range of 15 to 35 terabytes in increments of 5 terabytes. And essentially add that to their existing SDDCs that are based on IC metal. There were a lot of capabilities that were announced, but one capability that really enables migration as well as hybrid use cases is the interconnectivity with Direct Connect with NSX riding on top of that. And this really enables our customers to accelerate the migration, but also build hybrid use cases where they can have certain parts of the application residing on premises and certain parts of it in VMware Cloud on AWS. The custom core counts, this is what Nathan was mentioning about disabling CPU cores. But essentially what this allows our customers to do is specify just the number of CPU cores they need per host, and this is applied cluster-wide. It's really geared towards reducing costs for mission critical applications that are licensed on a per core basis. We announced that we are reducing the minimum production cluster size from 4 hosts to 3 hosts. In addition to that, we are also running a special promotion from September 10th onwards where a customer can purchase this at the price of 2 hosts. And this essentially reduces the entry price for production environments by 50%. New encryption capabilities with vSAN leveraging Amazon KMS, vSAN software-based encryption leveraging Amazon KMS is another capability that we announced where vSAN software-based encryption would apply to not only those R5 hosts that use EBS storage, but also those i3 metal hosts that have local SSD devices. We talked about microsegmentation, which really allows NSX to provide that granular control for east-west traffic between application workloads running in VMware Cloud on AWS, basically building out that security story and helping secure applications and build compliant environments. One of the things that we also announced was a set of compute policies, and this really allows our customers to be able to implement VM host placement constraints. The first one being VM host affinity, which allows our customers to associate VMs to a specific host group within a VMware Cloud on AWS SDDC cluster. There is also, this is really good for applications that you want to pin a set of VMs to a set of hosts. And then we also have disabled DRS vMotion, which is ideal for vMotion sensitive workloads. Now, all of these capabilities or compute policies are preferential, which means that at an event that includes infrastructure host remediation, that would take precedence over these compute policies. Now, I would like to leave you with this slide where you can actually get started with our single host for proving the value of VMware Cloud on AWS, as well as go into production workloads with the 3-host configuration. With that, this brings us to the end of today's presentation. I hope you have learned some useful information. Please do go and check out our website, cloud.vmware.com/vmc-aws for more information.